Okay, so I've filtered for EIGRP in this Wireshark capture. First question we asked is which version of EIGRP is used. I'm going to go through this in a little bit more detail. First thing you'll notice is at layer 2 of the OSI model, in other words, at the Ethernet layer, we've got an Ethernet frame. Source MAC address is this, destination MAC address is this. This is the well-known multicast address for IP version 4. Vendor code is 01005E. This portion is determined by the IP version 4 address. It's actually the last 23 bits. A in hexadecimal is 10. So this is the MAC address for this IP version 4 multicast address. Ethernet type is 0800. This is IP version 4. In other words, IP version 4 is used at layer 3. We can see that once again, source IP address, destination IP address. This is actually router 2 sending a hello. Here's router 1 sending a hello. But let's go back to router 2. Differentiated services code points. DSCP is set to class selector 6. In other words, this is very important traffic, more important than voice or other traffic. Protocol is EIGRP. Protocol number for EIGRP is 88. So at layer 4, EIGRP is the protocol used. Version is version 2. Okay, so in our questions, we can say that it's version 2. That is the version number of EIGRP, as we can see in the Wireshark captures. Is authentication used? That's the next question. Let's have a look through the messages. So we can see this is a hello message. We can see the autonomous system number, and we can see authentication as MD5. So we can answer a few questions there. So AS number is 100, as shown over here. Autonomous system number is 100. Authentication is used, and it's MD5. So MD5 authentication. That's better than using clear text authentication. So authentication is MD5. Notice the digest is set as follows. It's not in clear text. In fact, it's still possible to hack that, but not as easy as clear text authentication. Okay, so scrolling down a bit further, we can see some parameters. Notice we can see the K values. K1 and K3 are enabled. So bandwidth and delay, those are the defaults. So if you're not sure why that is, you need to do some studying. Once again, you get access to my CCNA course, so that will help you work that out. But if you're not sure ever, once again, just use Google. So here's my browser. I'm going to simply search for EIGRP K values. Like all things in life with networking, do a search in Google. If you're not sure, there's often very good explanations of the values. So just on this website, I see bandwidth and delay are the two that are set. We can see that here, K1, K3. It's better to get that information from Cisco's website, but I mean, there are many websites that give you that detail. This is on DuckDuckGo, but let's look on Google. So EIGRP K values. You can see that people have been searching for this already, so I'll select that option. Various websites that mention this. What I'll do is do a search for cisco.com. So we get the information from Cisco. So as an example here in the Cisco forums or the learning network, people are asking for the explanation of what they are. Someone actually did a Wireshark capture here to see what they should be set to. So that's what we're actually seeing. And here's probably a better document. So straight off Cisco's website, here are the K values explained, and they are the default values. That's what we're seeing in the output here. K values are set to that. And if we look at both routers, you'll see the K values are the same. So there's router 1, here's router 2. K values are the same. Authentication is set on both routers. Notice the authentication is the same on both routers. It needs to be. In MD5, it's a hash of the original value. If you change the original value, the hash will change. So here the hashes are going to be the same because the same password is used. Okay, so here's another one. Which routes are advertised by the routers? So if we look at the update messages, we don't see routing information. Let's go down. Notice this is a bigger message, 183. Let's see if we can see routing information. Yes, we can. Notice there's an internal route, 2.2.2.2/32. That's a route advertised by router 2. It's also advertising this internal route, 10.1.2.0/24. So you might not know this by just looking at this diagram. I've purposely tried to make it a little bit more difficult, but this network 10.1.2.0 is over here, and the router has a loopback address of 2.2.2.2. What I'll do actually is show you that so you can see that. So show IP interface brief. The loopback has this IP address. Gigabit 01 has this IP address, that's over here. Gigabit 00 has this IP address, that's over here. So the router is advertising the remote networks, not the local network. Both these routers are on the 10.1.3 network. So notice they are advertising to each other on 10.1.3. So that information is not advertised in the routing update. The remote networks are advertised. So there you go. 2 routes are advertised. I mean, there you can see the IP address of the router sending the update. Okay, let's look at router 1. Router 1 is advertising this loopback, 1.1.1.1/32, and this network, 10.1.1.1.0/24. Loopback is here, 10.1.1.0 is on this side. We can see that once again by looking at the console of router 1. So router 1, show IP interface brief. Loopback, interface on this side, so network on this side, network used between the 2 routers. So I was able to answer those questions by looking in Wireshark. So router 2 is advertising this, and 10.1.3.0, it's actually 2.0, and router 1 is advertising this and 10.1.1.0/24. So those are the routes advertised by each router. Okay, how did you get on? Were you able to answer these questions? Were you able to work it out by simply looking at the Wireshark captures? It's not always easy, but there's no better way to learn Wireshark and learn packet analysis than be forced to try and work it out. If I just give you the answer, you're not going to remember. But if you're kind of forced to work it out, you'll probably remember it better.